In the world of data science and engineering, we often talk about algorithms and models, but the foundation of every breakthrough is the infrastructure that supports it. My journey into system architecture didn't start in a server room. It started with a realization that the tools I had were no longer sufficient for the scale of my ambitions. Hi, I'm Arpit, and in this video, I'll walk you through how I set up my server, my main compute unit, and how it helps with my machine learning workflow. During the second year of my engineering degree, I reached a technical plateau. My hardware was nearly a decade old and incapable of handling the computational demands of modern development. I moved to a custom built PC, my first real laboratory for tinkering with data structures, game modifications, trying to understand how memory placement works, and all sorts of experiments that an engineer would do. This was my entry point into data science, but there was a lot of issues. It was far from optimized. Since I was running an AMD GPU, I lacked access to CUDA ecosystems. So to compensate, I had to write custom OpenGL codes for basic matrix multiplications and regression modules. It was an arduous process, but it did provide a fundamental understanding of how hardware communicates with software. It made the eventual need for NVIDIA architecture an obvious necessity rather than luxury. To support local LLM and deep learning training, I transitioned to an RTX 4070 Ti Super with 16 gigs of VRAM and 8400 CUDA cores. The bottleneck shifted from the GPU back to the platform itself. Because I had invested in a high quality X470F motherboard early on itself, the upgrade path was pretty clear. I was able to drop in a 5700X 3D, ensuring the CPU could keep pace with the new GPU. Now the bottleneck was cleared, my old GPU was free to use somewhere else, and it was a lesson in the value of making substantial hardware decisions early in the lifecycle itself. A power outage recently compromised my older 700 watt SMPS, highlighting a single point of failure in my setup. I had upgraded to an 850 watt cold unit, but I also realized that I needed a dedicated low power server, something that could be operational even on an inverter during outages. I had few older parts laying around like my older CPU, my GPU, some storage. All I needed to buy was a good SMPS, a motherboard, and a RAM. Building the server required a balance between cost and reliability. I opted in for new parts over second-hand components to mitigate the risk of hardware failure. The ones I already had, I knew they were working fine, so I used them anyway. For the operating system, I bypassed the graphic user interface entirely. I installed Ubuntu Server. So by going headless, I eliminated the 2 GB RAM overhead of a desktop environment, dedicating every available cycle to my ML services and the projects. The software stack was designed for professional ML lifecycle. I integrated MLFlow for orchestration, PostgreSQL for database management, MinIO for object storage. For experiment tracking and security, I deployed MLFlow and Vault 1. To bridge the gap between my local network and the world, I utilized Nginx for traffic management and Cloudflare Tunnel for securing web services. For remote access between my laptop and my main PC, I implemented Tailscale, and it created a secure mesh network without needing the traditional port forwarding setup. What began as a struggle with an aging laptop has evolved into a robust multi-node infra. I didn't just build a computer, I built a system that allows me to develop, train, and deploy at scale. The hardware is ready, the stack is live. Now it's time to code. See you in the logs.